morning dear students, welcome back to our online class. Today we will discuss about the next unit of the chapter light, refraction of light. Okay students, so first we will show a smart class video to understand this topic better. Okay students, here refraction of light. What is the refraction of light? How reflections takes place when a light travels from one medium to another medium. Okay students, so first you will seriously and sincerely just watch this smart class, this short clip video, try to better understand this topic. Then we will later discuss about this in detail in next class. Okay students, so kindly watch this smart class video for better understand this topic, the reflection of light. Okay students, so please kindly watch. Okay students, thank you.
What can happen when a beam of light is incident on the surface of any object? When a light beam is incident on the surface of any object, a part of the light can be reflected by the object, a part of the light can be transmitted. That is, it may pass through the object and get out from the other side, and a part of the light can also be absorbed by the object. The amount of light reflected, absorbed or transmitted depends on the material that the object is made up of. If an object is opaque, then it will absorb and or reflect most of the light back. If it's transparent, more light will be transmitted. Can you think of examples for these two? The surface of a mirror is shiny and opaque, and most of the light rays are reflected from it. On the other hand, glass is an example of a transparent object. It will transmit most of the light. So what is refraction of light? Here's how we define it in simple words. It's simply bending of light when it travels from one medium to another. Yes, if it is incident at this angle, then it goes through at another angle. Now this is not the exact definition as there are a few technicalities involved. Let me explain it to you. Consider a transparent object kept here, say a glass slab. Suppose light traveling through air is incident obliquely on the surface of the glass. What do I mean when I say obliquely? It means slant. It implies that the incident ray is neither parallel nor at a right angle to a specified line. Now this light will bend at the boundary of the two media. Here the two media are air and glass. This bending of light at the boundary of the two media is what we call refraction of light. We see that at this point the light bends. It's not going straight. What are these two mediums called? The medium from where the light is incident is called the incident medium, and the medium where refraction occurs is called a refractive medium. Similarly here as well, the light is traveling from one medium to another medium. It's from glass to air. And here also it is incident at an angle. Since we know that air is a transparent medium, light bends at this boundary and travels through air. So light refracted at these 2 points. Let us draw a line perpendicular to the surface at this point of incidence. This line is also called a normal. What is this angle called? It's called the angle of incidence and is denoted by the letter I. It is an angle made by the incident ray with the normal. And this is the angle made by the refracted ray with the normal. It's called the angle of refraction R. Now there might be various questions that you have. Why does refraction occur? Why does light change its direction after entering another medium at an angle? Why does incident light have to be slant in order to change its direction? Can the refraction occur if the light enters perpendicular to the surface? We will answer all these questions in the coming videos. In the previous part of this lesson, we saw what refraction of light is. It's simply the bending of light when it travels from one medium to another. The question I left you with was, why does light change its direction after entering another medium at an angle? Let's discuss that in detail. The change in direction of light occurs because of the change in the speed of light in that medium. When light enters another medium, there is a change in its speed. The speed may either increase or decrease depending on the medium. Note that when we say that the speed will increase, it does not mean that the speed will be greater than this value, which is the speed of light in vacuum. When the light is entering into the glass at an angle, it travels at a lesser speed than in air, and when it goes from glass to air, its speed increases. So it's because of this change in speed that the direction of light changes. But what if the light is entering perpendicular to the surface of the glass? Will its speed change? Yes, its speed will change, however, it does not bend this time. Yes, the refracted ray propagates in the same direction as the incident ray. Talking about the case when light enters at an angle, there is one more observation that we can make. Observe this part of the refraction. Observe the incident and refracted rays. We notice that the refracted ray is more towards the normal than the incident ray. When the light rays enter the glass from air, it bends, and it bends towards the normal. And from this refraction, we can see that when the light ray again enters the air, it bends away from the normal. So we can say that when the light travels from an optically rarer medium to an optically denser medium, it bends towards the normal. And when the light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. What do we mean by optically rarer and denser mediums, by the way? An optical medium is a medium through which light can propagate. Since both air and glass are transparent, light can pass through them. So, both of them are optical mediums. What about rarer and denser? If the refractive medium is optically rarer compared to the incident medium, then the speed of light in it will be greater. And when the refractive medium is optically denser compared to the incident medium, the speed of light in it will be lesser. Note that in both cases, we are comparing the speed of light with the speed of light in the incident medium. So what do we understand by this? How can we summarize it? When light is traveling from an optically rarer medium to an optically denser medium, its speed will decrease and it will bend towards the normal. Whereas when the light is traveling from an optically denser medium to an optically rarer medium, its speed will increase and it will bend away from the normal. Now that this is clear, I want you to understand another concept. Now, instead of a glass slab, we have water, and also suppose that the ray of light is incident in the same direction. We can see that this angle is the same in both the cases. So will the refracted ray in this case travel in this direction only? In other words, will the angle of refraction be the same in both cases? No, the angle of refraction will be different in this case. In fact, the angle of refraction here is greater than the previous one. So what can we infer? We can say that the refraction of a light ray depends on the material medium on which light is incident. Yes, light rays will be refracted by different amounts in different materials. But wait, I have a couple of questions for you. Talking about the case when light enters at an angle, how does the change in speed result in the change in direction of light? And why does this perpendicular ray not change its direction after refraction? I know you must be curious to know the answers. However, we'll understand this in the next video. It's really interesting. Make sure you watch it. Refraction of light is a transmission of light through an object in which the light which is incident obliquely bends at the boundary of the two media. We also said that the bending of light in the medium is caused by the change in its speed. When light is traveling from an optically rarer medium to an optically denser medium, its speed decreases and it bends towards the normal. When the light is traveling from an optically denser medium to an optically rarer medium, its speed increases and it bends away from the normal. In the figure, the case above is from optically rarer to denser, and the case below is optically denser to rarer. But how does the change in speed result in the change of direction of light? I did mention in my previous video that we will understand this with the help of an analogy. For the next few minutes, just forget everything I told you about anything related to light and just concentrate on what I'm about to show you. Here's a shopping cart which has rotating wheels. Say I want to move this shopping cart from the road to the grass. Obviously, I will push it or apply a force on it. Assume that I will apply a constant force throughout its journey. Let us see what happens when I start to move from concrete road to the grass. What did you notice? As the wheels of the cart entered the grass surface, their speed reduced. The cart travelled at a much lower speed on grass than on the concrete road. And the reason for slower speed is rather obvious. The grass offers more resistance to the motion of the cart than the concrete road. Here, we can consider the concrete road and grass as two different media through which the cart is moving. Note that the direction of the cart is same in both the media. We can think about light in the same way. Something similar happens when the light is travelling perpendicular from an optically rarer to an optically denser medium. The optically denser medium offers resistance to the flow of light and hence its speed reduces. However, its direction does not change. Let's get back to our cart example. What will happen if the cart enters the grassy surface at an angle? Let us see that. This is how it would look. Now let's take the cart back to the original position on the road, and we will look at the movement very slowly. As the cart approaches the grass surface at an angle, its right wheel will enter first, and as it enters here, it will slow down. At that time, the adjacent wheel is still on the concrete road and is hence moving with the same original speed. So the wheel on the grass surface will move slower than the other wheels for some time. But let's focus on the two front wheels. Both the wheels are moving with different speeds. As the force applied is constant, what this will do is slightly turn the cart towards the right. The cart will change its direction and continue moving in that direction afterwards. So the direction changed. Now let me draw a normal to the surface now. We can see that the cart has taken a turn towards the normal. If the surface wouldn't have changed, the cart would have continued to move in this direction. But because the surface changed, the direction of movement of the cart also changed. Why am I telling you all this? It's because one can think of bending of light in the same way. When light is obliquely incident on the surface of an optically denser medium, its speed decreases and it bends towards the normal. Part of the beam that enters optical medium first slows down, making the entire beam to change the direction towards the normal. Now let me ask you a question. How will the direction of light change when it enters an optically denser medium to an optically rarer medium? Will it move towards or away from the normal? To answer this question, let's switch back to the cart example. This time, the cart is here on the grass and it's being pushed towards the concrete patch. What will happen here? This is how the direction of the movement of the cart will change. Why? Let's see the animation slowly. As the cart begins its movement, the right wheel will reach the boundary first, and after entering the concrete patch, its speed will change. Will it increase or decrease? It will increase. It's because the friction is lesser on the concrete road. So now, this wheel will move with greater speed, but its adjacent companion is still on grass moving at a slower speed. So the change in their relative speeds will turn the cart towards this direction. If I draw a normal, you can clearly see that it's moving away from the normal in this case. If the surfaces were the same, it would have moved in this direction. But as they are different, the direction as well as the speed of the cart changes. We can apply the same analogy for the light entering from an optically denser medium to an optically rarer medium. Light can propagate more easily in an optically rarer medium than in an optically denser medium. In such a case, its direction of propagation will be away from the normal in the refractive medium. One last question to which you will definitely know the answer to. What if the cart is entering the concrete like this, perpendicular to the surface? Yes, its speed will increase, but its direction will not change. So if the light is entering an optically rarer medium in a perpendicular manner, then its speed will increase, but its direction will not change. In the next video, We will talk about a few examples of refraction.
Thank you and cooperating for watching this video, students. Okay, so tomorrow we'll discuss about this topic, the refraction of light, in detail. Okay, students, thank you. Have a nice day.